one last issue which we will see about the Sanskrit language, Panini's. So we saw so many things, rule-based, how unambiguously one can create structures, one can add and modular fashion and all that, disassemble and understand. All these are very interesting concepts, and all these can be very useful building blocks for the natural language processing efforts that are going on now. So what is this NLP? It is mainly concerned with processing of natural language data using computers and programming techniques. A machine should be able to process the words that it hears and lipis that it sees. That's what it is. So it uses ideas from linguistics, computer science, artificial intelligence, all that, to make natural languages understandable to computers, so that computers can carry out actions based on the instructions given in a natural language. If there is a way we can do it, nothing like that. NLP, there are two subset of ideas, sort of, if you think. One is natural language generation, which means the machine must be able to put together all these components and start writing a paragraph or a story, if required. Generating text from a meaning representation using a logic implemented through the computer program. That is natural language generation. You call it as NLG if you want. Or natural language understanding, distilling the meaning from a natural language data using computer program. I feed a sentence and the computer is able to actually make sense of what is, there is a third case, there is a plural, there is a singular, there is something happening, somebody is eating, there is a verb and verb has this form. This is what is the other part, natural language understanding. Now, NLG is slightly easier because you give some rules, then it will try to use the rule-based constructs. Particularly if you have rule-based constructs available, use that lexicon and syntax available and generate the words. So NLG may be slightly easier. And now, for all that we have seen, you would have noticed that there are certain inherent advantages in the structure of the Sanskrit language and the Paninian grammar mechanism that makes it an attractive candidate for NLP and artificial intelligence related work. This is what a few people are saying, and there is some serious work which is anyway happening in all these areas. So, for example, take this, Balaha Vrikshasya Palam Kadati. This is a sentence. Now, for all that I said earlier, the computer can easily, because Panini puts everything and finally comes to Balaha. Vrikshasya is also derived, Palam is also derived, Kadati is also derived, everything is derived. So, if you know how it is derived, you can dismantle them. So, what happened? This table shows that Balakaha actually has a Bala, which is the noun root, and a first case termination has been added to it, that's why it became Balaha. Then you have Vriksha, which is a noun base again, and there is sixth case, Vrikshasya is sixth case, so it understands it will be attached to some Karaka and so on. Then Pala is again a noun base, and Palam is actually the object, second case, so it understands, that is what is happening. And Kad is to eat, and Kadati is present tense, simple present tense. Because the language was all put together like this, you can also tear it down. And that is very useful for the computer. It's a headway for the computer to do natural language processing. It is actually difficult for a computer to comprehend natural languages like humans, as there are many ambiguities in natural languages. When we use words having multiple meanings, there is ambiguity about the meaning, which meaning to take. Humans are able to remove the ambiguity by the context. So, how do you build actually context? So, let's take an example, pious. Pious is a word used in Sanskrit for both water and milk. Now, the question is, if pious appears somewhere, how do you actually decide? When we hear the sentence, Nadyam payaha pravahati, meaning pious is flowing in the river, we immediately resolve the ambiguity. We know, milk doesn't flow, only water flows. That we know. How do we actually, so we have to put some of the logic for this also. So this is called Yogyata in Indian linguistics. How do you establish Yogyata? Which is the most eligible fellow? So Indian linguists have actually described 14 such determiners to fix the meaning of a word in case of multiple meanings. So that kind of work has also happened. The Yogyata kind of work has also happened, which is also very handy. So basically what we are saying, the Sanskrit language has certain inherent features such as being derivational and inflectional. That is good news. Availability of full-fledged generative grammar for Sanskrit in the form of Ashtadhyayi. It lends itself as a very potential candidate for use in NLP. Therefore, in recent years, several researchers across the world have worked in the area of Sanskrit computational linguistics, have actually developed several components that actually helps in NLP using Sanskrit. And so this is a great work in progress. All that I wanted to say is, by ending this module on linguistics and particularly the Sanskrit language, which all our ancient Indians have greatly contributed, is that it seems to have very attractive building blocks. Maybe some additional work, some incremental work is required, but with all that, one can put Sanskrit into NLP. A lot of work is already going on. Sanskrit computational linguistics is a big thing that you find. Several components have been developed. I have not gotten into all those details because that is not the scope of what we are doing now. But some interested people can always see it, and therefore that's where the contribution of the Indians have also come in some ways through Panini by his magnum opus called Ashtadhyayi.